We are drifting in a mind-bogglingly vast cosmos, surrounded by trillions of colossal galaxies, each packed with hundreds of billions of blazing stars. Space is so unimaginably massive that mapping every single galaxy is an impossible dream. Yet, using super telescopes like Hubble and James Webb, we have charted billions of these cosmic islands, peering directly into the deepest, darkest corners of the universe. Today, we harness this jaw-dropping knowledge to launch the ultimate voyage, a mind-bending trip through the fabric of space and time itself. We will break free from our home galaxy and race toward the absolute edge of reality, uncovering the most terrifying and spectacular cosmic landmarks in existence. Prepare yourself. This is the ultimate journey to the edge of the universe. But before we launch into the void, we must answer a chilling question. Where does the edge of the universe actually lie? When we speak of outer space, we are usually talking about the observable universe, a colossal boundary known as the Hubble volume. This is a gigantic bubble-like sphere centered around Earth, containing every single galaxy and speck of matter we can detect. Why? Because their light has finally had enough time to cross the abyss and reach our sensors. Light screams through the dark in every direction at a mind-melting speed of 300,000 kilometers per second. But while that seems instantaneous to us across the terrifying scale of the cosmos, light is agonizingly slow. Every step we take beyond the Milky Way plunges us into a massive time lag. This delay acts like a cosmic time machine, showing us objects exactly as they looked in the ancient past. If a galaxy is 1 billion light-years away, we see it as it was 1 billion years ago. Ultimately, the edge of the universe is not just a physical wall, but a temporal barrier locked by the cosmos's age of 13.8 billion years. The observable bubble only holds galaxies whose light has traveled for less than 13.8 billion years. The deeper we peer, the closer we get to the violent birth of creation itself. Therefore, traveling to the edge of the universe is a thrilling race back to the absolute beginning of time. They say telescopes are time machines, and the James Webb is the ultimate vessel. Its razor-sharp infrared eyes are piercing the darkness right now, capturing the cosmos at every stage of its epic evolution. Throughout this cosmic lifespan, space itself has been violently expanding. We see the undeniable proof of this expansion in the light reaching us, which gets stretched and reddened in a bizarre phenomenon called redshift. Redshift happens when light waves traveling to Earth get stretched out because the very fabric of space is tearing them apart. As the universe inflates like a colossal balloon, new space stretches the gaps between galaxies, pulling light waves along with it. This shifts visible light toward the red end of the spectrum, serving as a cosmic speedometer to calculate the staggering distances between galaxies. This redshift value, known as Z, gives us the ultimate roadmap to begin our epic journey into the deep unknown. We start on Earth, a microscopic, utterly insignificant speck lost in the cosmic ocean, dwarfed by our own solar system and completely swallowed by the galaxy. Our sun is merely one spark among a mind-boggling 100 billion stars, countless numbers of them harboring their own alien worlds. Yet the true spine-chilling scale of the cosmos only begins to unravel once we break free from the borders of the Milky Way. Our home galaxy is just the runner-up in a desolate cosmic neighborhood called the Local Group, a cluster of over 30 galaxies and hundreds of dwarf satellites. This local neighborhood spans a staggering 10 million light-years, though its 4 dominant powerhouses are packed terrifyingly close together. Unbelievably, the 3 largest giants are locked on a fatal collision course, dragged together by relentless gravity, defying the very expansion of space. This is why we see no cosmic expansion until we venture far beyond our local borders. Stepping outside, we plunge into the vast local volume, a massive cosmic zone stretching 30 million light-years in every direction from Earth. Reaching deep into the cosmic void, this zone traps over 500 spectacular neighboring galaxies, all clustered into their own chaotic cosmic families. Looming just beyond is the ominous Council of Giants, a colossal ring of 12 massive galaxies standing guard around our local neighborhood. These monster galaxies rule over their own cosmic empires, like the chaotic Sculptor Group, governed by the spectacular Sculptor Galaxy. Known to science as NGC 253, this starburst beast lies 11 million light-years away, violently birthing new stars at a frantic pace. It burns with a blinding, ferocious light, outshone only by the mighty Andromeda and the mysterious Sombrero Galaxy. Messier 104, famously called the Sombrero Galaxy, is a bizarre alien anomaly with a massive glowing core and a dark ring of dust. Its ghostly halo radiates with a blinding intensity that eclipses the Sculptor Galaxy, despite being half the size and 3 times more distant. It belongs to a stream of 100 smaller galaxies drifting away from the gargantuan Virgo cluster. Deep within its constellation, the Virgo cluster is a hyperdense cosmic metropolis, packing over 1,500 galaxies into the most colossal structure in our cosmic backyard. At its very heart lies a terrifying titan of the cosmos, Messier 87. This supergiant elliptical monster harbors trillions of ancient stars and 15,000 star clusters. Deep inside its core lurks a monstrous supermassive black hole, packing the mass of 6 billion suns. This is the very beast that shocked the world in 2019, when scientists captured the first ever image of a black hole, ending a decade-long hunt to reveal the invisible. This monstrous black hole is a prime target for astronomers, violently blasting a high-energy jet of plasma thousands of light-years into the cosmic void. It stands as one of the most blinding radio sources in the known universe. But this galaxy, our own Milky Way, the massive Virgo cluster, and over 100 other colossal galactic groups are all being dragged into a mind-bending intergalactic structure. This titanic web stretches far beyond our imagination, spanning over 150 million light-years. This is the Virgo supercluster, a colossal cosmic empire harboring thousands of galaxies across a staggering 100 million light-years. Yet this mind-blowing scale is just the beginning of the cosmic web. The Virgo supercluster is merely a single branch of a far more terrifying network, mapped by the chaotic motion of galaxies rushing through the dark. This supreme cosmic megastructure is known as Laniakea. It traps over 100,000 galaxies, sprawling across a mind-numbing 500 million light-years. Even though cosmic expansion keeps these galaxies from merging, the sheer gravitational pull of this web forces them to drift together. It is a slow, haunting dance, much like leaves reaching desperately toward the sunlight. For decades, we had no idea what they were drifting toward. The mysterious heart of Laniakea was completely blinded by the thick, dusty shroud of our own Milky Way. This invisible monster, the Great Attractor, remained a terrifying cosmic mystery. But revolutionary new technology has finally pierced this forbidden zone of avoidance. By using powerful X-rays and infrared vision, scientists cut through the galactic dust. There, hidden in the shadows, they exposed the true source of the Great Attractor, buried deep inside the Hydra Centaurus supercluster. Deep within this abyss, 250 million light-years away, lies the Norma cluster. This is the beating heart of the Great Attractor, pulling all of Laniakea toward it. Yet this cluster alone isn't powerful enough to explain the terrifying speed at which we are falling. An even greater unseen force is pulling the strings. Lurking far beyond Laniakea, over 650 million light-years away, lies the Shapley supercluster, a hyperdense, colossal graveyard of thousands of gravitationally locked galaxies. And even further in the deep dark, nearly 900 million light-years away, looms the massive Vela supercluster. These two cosmic titans are secretly pulling on Laniakea from afar, supercharging the Norma cluster and generating the irresistible gravity of the Great Attractor. But remember, Laniakea and the Virgo supercluster are not bound by gravity. They are slowly tearing apart, raising a haunting question: do these cosmic structures even truly exist, or are they just temporary ghosts in an expanding universe? Yet, the cosmic web hides structures so mind-bogglingly massive they dwarf even superclusters, known to astronomers as titanic galaxy filaments. These are the absolute monsters of the cosmos, colossal threads of bound galaxies stretching across a staggering distance of over 250 million light-years. But brace yourself, because some of these structures get even more insanely massive. 1 billion light-years away lies a terrifying cosmic megastructure, The Sloan Great Wall, a jaw-dropping cosmic barrier mapped using data from the Sloan Digital Sky Survey. This structure forms a massive glowing arc of pure galactic power, packed into a hyperdense region of space. Locked within its grasp are multiple packed superclusters, anchored by the gargantuan gravitational beast, known as SCI 126, right at its center. Spanning an unbelievable 1.3 billion light-years, this structure defies imagination. Yet astronomers still clash over whether this cosmic giant is one continuous, unbroken megachain or just a deceptive alignment of three separate superclusters and filaments mimicking a single colossal entity. Regardless, when discovered in 2003, the Sloan Great Wall instantly shattered records as the largest structure in the known universe, holding that crown for a decade. Pushing past the Sloan Great Wall, we cross a threshold over 1.3 billion light-years from Earth, entering a realm of extreme cosmic time. Beyond this point, we are looking back over 1.5 billion years into the deep past, witnessing the chaotic, violent infancy of a younger universe. In this ancient epoch, galaxies like our own Milky Way and M31 were locked in brutal, destructive collisions, crashing into their neighbors and violently merging their stars and gas. These catastrophic cosmic impacts funneled insane amounts of star-birthing gas directly into galactic cores, ignited by the crushing, chaotic gravitational tides of the merger. And when this massive amount of gas feeds the supermassive black hole lurking at the center, it triggers mind-bending, violent electromagnetic phenomena that defy belief. This feeding frenzy creates what astronomers call an active galactic nucleus, a cosmic powerhouse unleashing torrents of blinding, radiant energy that outshines entire galaxies, blasting extreme power across the electromagnetic spectrum, especially in the form of intense radio waves. These are the legendary radio galaxies, cosmic beacons typically born inside giant elliptical galaxies like M87. As orbiting gas gets superheated and ionized, subatomic particles are trapped by the black hole's hyper-powerful magnetic fields and violently funneled toward its polar axes. From there, twin relativistic jets blast this matter away from the event horizon at near-light speed, launching high-energy particles across thousands of light-years into the deep void of space. This cosmic blowtorch glows with intense radio-loud synchrotron radiation, creating massive structures that completely dwarf the visible light of the host galaxy itself. That is why these radio giants scream across the cosmos, making them far easier to spot in the deep universe than ordinary quiet galaxies. Right at this cosmic boundary lies 3C 327, a terrifying example of the thousands of radio galaxies lurking in the dark. At 1.5 billion light-years deeper, we encounter the ultimate titan, Alcyonius, a record-breaking monster with radio plumes spanning a mind-blowing 16 million light-years. Yet lurking right between these two cosmic beasts is the mysterious 3C 273. But this isn't just any ordinary galaxy. We are staring at a quasar, the most violent, blindingly bright, and energetic monster in the entire cosmos. Unlike a typical radio galaxy, which is powered by massive jets shooting from its core, a quasar's terrifying power is fueled by a colossal swirling accretion disk surrounding a supermassive black hole. Inside this spinning vortex, subatomic particles are whipped into a frenzy at near-light speeds, violently smashing into each other and generating friction on a scale that defies imagination. This extreme friction superheats the disk to millions of degrees, unleashing a blinding torrent of radiation that is 50 times more efficient than the nuclear fusion burning inside our own sun. The result is a mind-boggling blast of pure, raw energy, screaming across almost every single wavelength of the electromagnetic spectrum. These cosmic beacons burn hundreds of thousands of times brighter than our entire Milky Way, easily masquerading as nearby stars despite being billions of light-years away from Earth. For years, they hid in plain sight, only exposed when astronomers detected their bizarre radio and ultraviolet signatures. Take the famous object 3C 273, once mistaken for a boring ordinary star, it was actually a cosmic powerhouse. Yet, these monsters are incredibly rare in our local cosmic neighborhood. While 3C 273 sits 2.5 billion light-years away, the vast majority of quasars lurk much deeper in the ancient past, when the young universe was a hotbed for these blinding beacons. To ignite this cosmic furnace, you need more than just a massive cloud of gas. The central black hole itself must be the perfect, terrifying size. If a black hole grows too gargantuan, like the beast inside galaxy M87, it becomes too big to shred incoming gas. Instead of chewing its food, it simply gulps it down whole, silencing the show. It is the violent shredding gravity of slightly smaller black holes that spaghettifies gas, ripping it apart into the subatomic fuel that feeds the blazing accretion disk. This is why the early universe, populated by smaller, hungrier black holes, was absolutely littered with these brilliant, glowing abysses of light. But to witness the true golden age of quasars, we must travel past redshift 1, over 8 billion light-years away. We are looking back to a time when the universe was less than half its current age. Out here, quasars explode into view in staggering numbers. This is a blessing for astronomers, because normal galaxies at this distance are far too dim and ghostly to study in detail. Yet these blazing beacons, shining from a peak epoch 10 billion years ago, light up the invisible cosmic web, illuminating galactic filaments like brilliant fairy lights on a cosmic Christmas tree. At 9 billion light-years away, quasars assemble into colossal formations that mirror the largest structures in existence, like the Sloan Great Wall. These massive quasar groups stretch across billions of light-years. Even though they aren't bound by gravity, these cosmic megastructures are still the largest entities ever discovered in the universe. Peer 8.8 billion light-years into the cosmic abyss, and you will encounter the first of 3 monstrous, record-shattering quasar groups, U1111. This colossal structure chains together 38 active galaxies, spanning a mind-boggling 2.2 billion light-years across. Right next to it, lurking even deeper in the cosmic dark at redshift 1.28, lies the Klaus-Campusano LQG. This is another terrifying cluster of 34 quasar galaxies, stretching over a staggering 2 billion light-years. But the true titan awaits at redshift 1.25. Here lies the huge LQG, an absolute behemoth of 73 quasar galaxies, sprawling across an unimaginable expanse of over 4 billion light-years. Yet, could this all be a cosmic illusion? Some scientists believe these megastructures are just random alignments, tricks of light playing on our eyes. Even so, they officially rank among the most massive structures ever discovered in the cosmos. But in 2013, a new titan dethroned the Sloan Great Wall. This ultimate cosmic giant is not a quasar group, but a colossal gamma-ray burst formation. These are the most violent, terrifying explosions in the universe, unleashing more energy in mere seconds than our sun will produce in its entire 10 billion-year lifetime. Unlike quasars, these cataclysms are born from stellar death, either the hyper-violent collapse of a dying supergiant star or the catastrophic collision of 2 neutron stars merging into a black hole. In both scenarios, a mind-numbing blast of gamma radiation is unleashed, lasting from milliseconds to hours, leaving behind a glowing trail that allows astronomers to map hundreds of these distant monsters. Lurking far beyond the quasar groups at redshift 1.6, astronomers stumbled upon a monstrous wall of these gamma-ray bursts. Spanning an absolutely mind-melting 10 billion light-years, they named this cosmic titan the Hercules Corona Borealis Great Wall. Although this wall is crowned as the largest structure in the known universe, it might not be a single, connected cosmic web. After all, gamma-ray bursts are localized cosmic fireworks occurring deep within individual galaxies. Because of this massive alignment might tell us very little about how the universe's grand web actually evolved over billions of years. Even trying to comprehend a distance of 10 billion light-years is enough to break your brain. It is utterly inconceivable. It dwarfs our entire existence, rendering all of human history and our struggles on Earth completely insignificant. The Hercules Corona Borealis Great Wall drags us all the way out to redshift 2, an astonishing 11.2 billion light-years away. At this extreme depth, we plunge back into the chaotic early universe, right into the heart of cosmic high noon, the absolute wildest era when star birth in the young universe reached a frantic, feverish peak. Just 2.5 billion years after the Big Bang, the cosmos was teeming with hyperactive star factories. These young, gas-rich galaxies were churning out a mind-blowing 3,000 to 4,000 new suns every single year. Compare that to our Milky Way, which slowly drips out a measly 10 stars per year. These primordial galaxies were violent hives of deadly ionizing radiation, dominated by blindingly bright quasars. Yet, at these extreme depths, even the most powerful galactic engines are sometimes completely swallowed by colossal foreground walls of cosmic gas. It is a universe of pure, unadulterated chaos. Believe it or not, a hot dog is actually a hot, dust-obscured galaxy. A blazing cosmic monster from the dawn of time, shrouded in a thick, suffocating cocoon of gas. Back in 2010, NASA's WISE telescope exposed over 1,000 of these beasts, lurking nearly 13 billion light-years away from Earth. But at these extreme distances, cosmic light begins to fade into mystery. Space itself expands so rapidly here that galaxies seem to flee faster than the speed of light. This relentless expansion stretches the very fabric of the cosmos, widening the vast gaps between galaxies until the space between them appears to balloon faster than light itself. Yet physics remains intact because the galaxies themselves aren't actually moving through space. Still, at 12 billion light-years away, objects vanish into the shadows. Their light is stretched to the breaking point, frozen in time, and starved of photons by the expanding universe. These ancient cosmic zones were once deemed completely unreachable. But today, a new generation of advanced infrared observatories is piercing the darkness, dragging the fading embers of this bygone era right out of the shadows. Unlocking the secrets of these primordial galaxies is a prime mission for the James Webb Telescope. What makes these targets so incredibly alluring to astronomers is the promise of finding population 3 stars, the very first generation of stars born directly from the raw, pristine gas of the Big Bang. When these first stars ignited the cosmic dawn, they triggered a mysterious, chaotic era known as the Epoch of Reionization, a massive, transformative phase transition for all the gas in the early universe. Following the Big Bang, cooling plasma condensed to form the universe's first neutral hydrogen and helium. But as this gas birthed the first population 3 stars, their blistering ultraviolet radiation began to reverse the process, stripping away electrons and violently re-ionizing the cosmos. Raging for 150 million years, this epoch finally ended when almost all neutral gas was transformed back into a charged, glowing plasma. The ultimate mystery remains. Did all galaxies share the work of reionizing the cosmos equally, or was the job dominated by a few massive, hyperluminous galactic powerhouses? To solve this riddle, scientists are hunting for the oldest, most distant galaxies lurking at the edge of time. Incredibly, telescopes have now spotted objects at mind-boggling distances of over 13 billion light-years. Deep within the constellation Ursa Major lies GNZ11, one of the oldest and most distant galaxies ever discovered. A tiny hyperactive pocket of superheated gas and ancient stars. This ghostly cosmic smudge likely formed a mere 420 million years after the Big Bang. An astonishingly rapid birth, considering that stars didn't even exist for more than half of that time. For years, the legendary galaxy GNZ11 reigned supreme as the absolute edge of our observable universe. But in 2022, Japanese astronomers shattered that record, capturing a mind-blowing, even more ancient cosmic monster lurking in the deep dark. This newly discovered beast, dubbed HD1, boasts a staggering redshift of 1327. It burst into existence a mere 330 million years after the Big Bang, practically hugging the birth of the very first stars. But this terrifying distance still awaits final confirmation from the James Webb Space Telescope, which has just spotted its own ancient rival, the mysterious glass Z13. Though not quite as distant as HD1, this primordial titan still sits at a mind-bending redshift 13, a shocking 13.5 billion light-years away. Trying to comprehend this scale is impossible, but the reality is actually far more terrifying when you factor in the relentless expansion of space itself. That 13.5 billion light-years only measures where these galaxies were when they first fired their light into the void. Today, they have been violently swept away by the cosmic tide, hurtling far beyond our reach at speeds faster than light itself. They are now estimated to be a staggering 33 billion light-years away, so incredibly distant that any light they emit right now will never ever reach us. As these cosmic structures vanish forever, we are left staring directly into the terrifying edge of the universe. At redshift 20, 13.6 billion light-years away, our eyes fail us. The optical universe ends here, marked by the dying embers of the very first population 3 stars. Beyond this boundary lies the ultimate cosmic mystery, the universe's desolate dark age. A haunting epoch after the Big Bang, but before the first dawn, when the cosmos was completely devoid of light, wrapped in total, suffocating blackness. We know this because space itself isn't actually black. It is completely colorless and transparent. The pitch-black void hiding behind the stunning deep-field images from Hubble and Webb is actually a window into a time when light literally did not exist. And tragically, this is the absolute limit of what we can ever hope to see with our own eyes. Past this invisible wall, no photons have had enough time to reach Earth. They were simply too far away when the universe began. As time marches on, older light will slowly trickle in, expanding the boundaries of our observable bubble. But these newborn galaxies will only appear as ghostly red shadows frozen forever in time. Until then, we remain trapped inside the Hubble volume, locked away from the rest of the cosmos by the impenetrable cosmic event horizon. Yet, this is still not the true end of our journey. There is one final, mind-bending destination left. While the dark age begins at redshift 20, it stretches all the way back to an insane redshift of 1090. Here lies the oldest relic in existence, the fading afterglow of the Big Bang. But this ancient glow has been stretched so violently by the expansion of space that it is no longer visible light. It has morphed entirely into the radio spectrum. No matter where you point an antenna into the night sky, you will hear a constant, ghostly hiss, the eternal echo of creation itself. While static usually comes from local interference, a tiny fraction of it hides a mind-blowing secret, the literal birth of our universe. The ultimate destination of this cosmic voyage is the universe's ultimate baby picture, a shocking snapshot captured just moments after the Big Bang, when reality was a mere 379,000 years old. This ancient cosmic glow started as intense, blinding light unleashed by a dying superheated plasma as it cooled to forge the very first atoms in existence. Every single light particle before this epic moment was swallowed by that chaotic plasma, leaving the dawn of time forever locked in total darkness. That makes this cosmic microwave background the absolute boundary of our reality, a cosmic curtain we can never look past. We measure the staggering size of our observable universe by tracking the journey of these ancient surviving particles of light. These relic photons have been screaming through the void for 13.8 billion years. Yet the space they crossed has stretched violently, expanding to a mind-boggling 46.5 billion light-years. This is the shocking reason why the observable universe spans a massive 93 billion light-years across, even though time itself is under 14 billion years old. But this boundary is just an illusion, dictated entirely by where we stand, how old the cosmos is, and the speed of light. If we teleported billions of light-years away, our cosmic horizon would shift, and looking back, our own Milky Way would appear as a faint, primitive red smudge. The edge we see is not the true end. A terrifyingly vast reality lies completely hidden, forever locked beyond this cosmic horizon. What lies out there in the dark? How far does the real universe go? Prepare to cross this ultimate boundary and plunge headfirst into the terrifying mystery of the unobservable universe.